Assalamualaikum to our lecturer, Encik Muhammad Hamzi bin Muhammad Safian. Today we want to present our problem-based task. Okay, my name is NURFADHILAH SYAFIQAH binti NIZAM. My matric number 01DDT19F2004 and my members.
My name is Siti NURULA'INI binti Muhammad Deni. My matric number is 01DDT19F2011.
And my name is AQILAH SUMAIYAH binti HAMTHAN. My matric number is 01DDT19F2106. Okay, I will present about question 1. So question 1 about interpret the characteristic between single mode fiber optic cable and multi-mode fiber optic cable in terms of core diameter, light propagation, intuition and application. So then we have to calculate the reflection angle at air force, the critical angle at core cladding interface, the numerical aperture. Next. Okay. Single mode fiber optic cable is only permit one mode of light propagate because its narrow diameter core. Multi-mode fiber optic cable feature a big diameter core that enable for the propagation of many light modes. The single mode refer to ability to fiber to propagate just one type of light mode at a time. So they also refer to ability of a fiber propagate numerous modes. Fiber core also diameter, wavelength and light source bandwidth, color shade, distance and cost are the most priority distinction between single mode and multi-mode. Also, a tiny diameter core is a single mode fiber optic cable permits just one mode of light to propagate. When a result, the amount of light reflection from as a light travels through the core reduces, decreasing intuition and allowing the signal to travel further. The diameter of multi-mode patch cable is generally 50 to 100 micron. And then they also provide large bandwidth at high speed across medium distance as light wave pass through the cable core at 850 or 1300 nm. They are divided into many routes or modes. Next. So this is calculation for question 1, which is the formula is N1 sin 1 equal to N2 sin R. This is to calculate the reflection. So first we have to enter the value of N1, which is 1.0, N2 is 1.48, and theta I equal to 28 degree. So first of all, insert the value only two formulas, so we can see after the subtraction we can get the value of 0.317 equal to sin theta R. So, first of all, then theta r equal to sin anti-clockwise 0.317 and the refraction value is 18.5. The next is we want to calculate the value of critical angle. So the formula is n equal to 1 per sin c. So first, the value for n is 1.25. So insert the formula 1.25 equal to 1 per sin c. So the total value for critical angle is 55.1 degree. Next.
Next is question 2. Wavelength division multiplexer WDM is one of the techniques in optical frequency division multiplexing. Explain the concept of WDM and build WDM block diagram. Next. Many distinct wavelengths can be sent over the fiber at the same time, which is a powerful feature of an optical communication network. There's a system that include features such as transparency, the fact that each optical channel can carry any transmission format is a key feature of WDM. Wavelength routing, the use of wavelength sensitive optical routing device allow communication network and switches to be designed using wavelength as a dimension. A multiplex, which is simply an optical combiner. In WDM combines optical signals from many sources of transponders. They are blended in such a way that their wavelength differ. A single optical fiber strand transmits the combined signal. A demultiplier breaks the incoming beam into its components at the receiving end, and each of the beam is sent to the appropriate receiver. Next. Multiplexing with WDM is conceptualized in the diagram above. It consists of 4 optical pulses with 4 different wavelengths. Each of the 4 senders produces data stream with a certain wavelength. The splitter demultiplies the signal at the receiving end into the original 4 data stream. Next, I will give to Fadilah Syafiqah to continue.
Okay, thank you to Aini. Okay, question 3. Question 3 is for a PON, passive optical network system utilize a passive splitter. It takes one input and split it to broadcast signal. Okay, next. Okay, this is a diagram passive optical network. Passive optical network is a technology that allows a single fiber from a service provider to offer a reliable broadband connection to many end customers. Individual clients utilizing PONs in a commercial setting are often just end users. Okay, from internet, PSTN and CATV go to optical fiber. In OLT, OLT is for optical line terminal. Okay, for optical fiber, go to passive optical splitter and go to ONU which stand for optical network unit, and go to user end or customers. Okay, next, architecture of a Passive Optical Network, the OLT, ONU, and ODN are the three primary units that make up the PON's architecture. The interface between the PON and the optical backbone network is the OLT. Each fiber lines OLT provided PSTN, Internet and CATV service to 16 to 128 end users. ONU provides a service interface to end users. And lastly, ODN connects OLTs and end user using optical fiber. Okay, that's all from us. Thank you.